Okay guys, this is physical science paper 1 of the IEP assessment November 2018. So now we are going to go through with you question 3, okay, of which it's going to be about friction, the sliding and the hailstones. Okay, now question 3, I'm just going to write that down. Question 3, okay. Okay, now they say the velocity versus time graph shows the motion of two different objects sliding in a straight line across a horizontal surface. Okay, so now if we can analyze this graph, we can see that what happens that object K, okay, is increasing in velocity. Okay, and then we've got object L, of which its velocity is less than that one of object K. Okay, now they say, now question 3.1, we are going to start with 3.1.1. They say, could friction be the cause of the change in the velocity for object K? And then they tell us to explain our answer. Now the answer to this question, guys, number one, it's no. Now the reason why we say that is because object K is increasing. Okay, remember, friction always opposes the motion of an object. Okay, so now if the object is increasing, if the velocity of the object is increasing, then that means the friction has no effect. Okay, now we're going to say because the velocity of an object is increasing. Okay, now 3.1.2, they say, could friction be the cause of the change in velocity for object L? Okay, now the answer here is yes. Now object L has less velocity compared to object K, of which they are in the same horizontal surface. Okay, so now this could be the reason why object L has less velocity compared to object K. So now let us go to 3.2. Now in 3.2, they say a hailstone of mass 0.7 kilogram falls from rest from the top of a storm cloud. The average acceleration of the hailstone while falling through air is 0.21 meters per second squared. The hailstone reaches the ground with a speed of 34 meters per second. Okay, now we are told, guys, now let us take note of these keywords. We are told that the hailstone falls from rest. Okay, so now we know already that our initial velocity is 0 meters per second, and we are told that the final velocity is 34 meters per second. We are given the mass of the hailstone, of which is 0.7, and we are given the acceleration, of which is 0.21 meters per second squared. Now this is the data that we must keep in mind when we start solving the problems. Now 3.2.1, they say define acceleration. Remember, guys, the equation, acceleration is change in velocity over time. Okay, so therefore in words, acceleration, okay, is the change in velocity per unit time. Okay, now let us go to 3.2.2. They say calculate the distance the hailstone traveled from the top of the cloud to the ground. Now guys, we are going to use the equation of motion here. We know of the equation v squared is equal to vi squared plus 2a change in distance, of which we note it as s. Okay, so now we need to make this the subject of the formula. Okay, so we're going to transpose the initial vi, of which is going to be vf squared minus v squared, of which is equal to 2a change in s. Therefore our change in displacement is going to be v squared minus v squared over twice the acceleration. So now we know the final velocity is 34, isn't it? So we're going to square it. We know that the initial velocity is 0, is going to be squared. Okay, now this is all over. We are told that the acceleration is 0.21. Okay, we have it in our data here, so it's times 2 times 0.21. Okay, now let us punch this into our calculator to get the answer. We have 34 squared, okay, over 2 times 0.21. Okay, and the answer we get there is 2,752.4 meters. Now that's the answer to the question 3.2.2. Now let us go to 3.2.3. They say falling objects normally have an acceleration of 9.8 meters per second squared. Explain why the acceleration of the hailstone is much less. Now this, it may be due to, okay, due to air resistance. Okay, this may be due to the air resistance. Okay, that is why the acceleration is slightly lower, or it's lower than the normal one, of which is 9.8 meters per second squared. Okay, now let us go to 3.2.4. Now they say on reaching the ground, the hailstone pierces 12 centimeters into the ground before coming to rest. Okay, now in 3.2.4 they say calculate acceleration of the hailstone while piercing the ground. Now we are going to revisit the equations of motion, guys. We know that Vf squared is equals to Vi squared plus 2a change in displacement. Now remember, guys, let us compile a new data now. They say on reaching the ground, the hailstone pierces 12 centimeters into the ground before coming to rest. That means our initial velocity is now 34 meters per second, and our final velocity is going to be 0 meters per second, isn't it, guys? And now we know that the change in lentuzana is going to be 12 times 10 to the power of negative 2. Okay, now this is going to be in meters. Okay, so now let us calculate the answer. Now we know that we need to make acceleration the substitute of the formula. Okay, so we're going to have V squared minus Vi squared is equals to twice. Okay, so now therefore A is equals to Vf squared minus Vi squared over 2 times change in displacement. So now the final velocity we know is going to be 0 squared minus the initial one we know is going to be 34 squared. Okay, this is going to be all over 2 times 12 times 10 to the power of negative 2. Okay, so we're going to punch this into our calculator and get the answer. We are going to have 34 squared over 2 times 12 times 10 to the power of negative 2. Okay, and the answer we get there is 4,816.7 meters per second squared. Okay, now that is our acceleration, guys. That is the answer to our acceleration. Now let us go to 3.2.5. Okay, now in 3.2.5 they say hence calculate the magnitude of the force the ground exerts on the hailstone. Okay, now guys, 3.2.5. now let us draw this situation. Okay, we have a hailstone. Okay, it pierces the ground. Now as it pierces the ground, we know that it's going to exert its weight, of which we say is force of gravity, of which is mass times the weight of an object, of which is mass times gravity. And we are going to have the force of which is going to act upwards. And now this is the force that is going to be exerted by the ground on the hailstone. Okay, so now we remember, guys, Newton's second law of motion, of which we say the summation of all the forces is equals to mass times acceleration. Okay, now let's take the upward motion as positive and the downward motion as negative. Okay, so now what we're going to have here, we know that the upward motion of which is the force that is exerted by the ground is going to be positive. So we're going to have Fg plus minus the weight of the hailstone, okay, is equal to mass times acceleration. Okay, therefore the force that the ground exerts on the hailstone is going to be mass times acceleration plus the weight of the hailstone. Okay, now we know that the mass of the hailstone is 0.7. We know that the acceleration is 4,000. We calculated it here. It's 4,800 and it's 4,816. Okay, 0.7. And then plus the weight, we know it's 0.7 times 9.8. Okay, 0.7 times 9.8. So now we're just going to patch everything onto the calculator and we can get the answer. It's 0.7 times 4,816.7, okay, plus 0.7 times 9.8. The answer that you get is 3,375.6 newtons. Now that's the force that the ground exerts on the hailstone. Okay, so guys, that was the end of question 3. Please stay tuned with us as we do the last question on November 2018.